teachers, and we're so cool because you all think I'm the coolest person ever, which is totally the right thing to think. I know. I'm awesome. I would want to hang out with me. We tell this great story every year, and it just helps people remember, and plus we just think it's fun. So we have this logarithm law. Now this is different than the definition of a logarithm we did yesterday. This law says log base b of a to the x, so x is an exponent, equals x times log base b of a. So if you look at that definition, which is on your paper, you should notice that what happens is you take this x and it slides down in front. That's how this x in front of the logarithm gets there. Now, here's the story that Mr. Graham and I like to tell. Okay? So you decide that you are going to go play basketball. Now, don't ask me why, but you decide you're going to go play basketball in the woods. Because it just makes sense. You're going to play basketball. There's a really great basketball court surrounded in this like opening in the woods. Okay? And you're shooting basketball, and you're not that bad, but you're not awesome. And you shoot, and have any of you ever shot basket and then got the ball stuck in between the rim and backboard? Yeah. Yeah. I definitely did. Yeah. Okay, and then you don't know how to get it down, correct? Yeah. So you're in the middle of the woods. It's not like you have a ladder to get through. You shoot the basketball, and it gets jammed up in there between the rim and the backboard. And you're thinking, oh no, I'm by myself. There is no, don't go in the woods by yourself, but you're by yourself, and you can't get the basketball. So what do? You're in the woods, right? You're surrounded by trees. You just happen to find a log. You take a log, and you throw a log at the basketball. The basketball's like you're gonna throw a log at the basketball, and the basketball comes down. It's the best story ever, right? This is the greatest illusion. But what we're going to have is, the reason that this will kind of make sense when you see it is you're going to be starting with an exponential, like 4 to the x. We don't know how to get the x out of the exponent, right? We've never been able to do that. But what we're telling you is that if you throw a log at it, and you put a log in front, this exponent rule says that log, or that basketball comes unjammed, and it sticks down in front of the logarithm. So when you throw a log at it, the exponent comes out, just like your basketball. Right? Do you like my metaphor there? Yeah. A simile? I used like, so it's really a simile. Yes. All right. Now, let's talk about this. So let's try some. Really basic ones to start. We are just using the logarithm law, just like I showed you, to remove the exponent. So we're going to simplify each one. So the rule says if I have an exponent in what I'm taking the log of, that exponent pops down in front of the expression. So log of x squared is really equal to 2 times log of x. Okay? All you're doing is moving the exponent in front. Log base 3 of x to the 9th, how would you rewrite that when I use my log? Yeah, 9 log. Yes. Okay, we're just applying the rule, and then we'll see where it's used. Then here, this x goes out in front. So you'll have x times log base 2 of 100. See how that log makes the exponent move in front? That's a rule. And there are actually a ton of logarithm laws and logarithm rules. This is the one we're going to do in our class. You're going to do a ton of them in pre-calc. So if you love logarithms, you're going to see them again next year. You will not get done with that. So now, let's get to the point of this logarithm law. The point of learning it. So for example, we're going to follow the steps that are listed to solve the equation 4 to the x equals 8. Right? We've been saying for days now, we want to solve these, but we have no way to get the x out of the exponent. But now I just tell you that rule. That says, take the common log of both sides. So here's what you're going to do. You're going to write it out, and we'll do it the long way for a couple, and then we can shorten it. Log of 4 to the x equals log of 8. So log is like an operation, just like adding and subtracting. If you do it to one side, you have to do it to the other. So that's our throw a log at it, right? We threw a log because we have an x up in the exponent. Our logarithm law in step 2 that we applied makes that x shoot down in front. So really what you have is x times log of 4 equals log of 8. Now it should be easy. How do I get x by itself? Divide by log of 4. Now you are not going to round. It even says here, don't round till the very end. Because we are going to get a bunch of decimals. I don't know in this example if we will, but in general, you're going to have a lot of decimals. You don't want to round till the end. So we're going to take out our calculators. And you're going to type that in. Now just be careful with the parentheses. I forgot to turn the calculator on here. Be careful with the parentheses. Make sure you close the top parenthesis for the logarithm before you hit the division. 1.5. Yeah, this one works out nicely. As we nicely. So pull it out, make sure. You do get 1.5 here.
Wait,
you have to type log. Oh, wait, you mean when you throw it, like do the equation?
Yeah.
The log's not going to be there, right? So hold on. Log, make sure you close the parentheses here, divided by log of 8. Okay? And that's what we got. Ooh, is that what we did? Or did it backwards? It's 8 divided by 4. I gotcha. It's been a long day. It's not a bad day. It's just been a long day. There we go, 1.5. All right, now Zach's question. When we started here, 4 to the x equals 8, there were no logs there. That's why I said we're going to throw a log at it, because that's like our basketball stuck up there. Until today, we had no way to get that x out. Now the way we get the x out is to take the log of both sides. Okay? Now, the beauty of this logarithm law, right underneath, is that it removes the variable from the exponent. Right? That log, that x is gone from the exponent. I want to remind you, if we use logarithm base 10, we just took the log of both sides. What is that one called? Log base 10. What was the name for it? Common. Good. Okay, so we're going to use the common logarithm if we just have numbers. We'll talk about when we're going to use the natural logarithm in a few minutes. All right, so for example, let's solve these exponential equations. So we'll do the one on the left, like writing it all out, and then I'll show you where it's okay to kind of like skip a couple things here. All right, I have x in the exponent. So, again, we want to get the x out of the exponent, so we throw a log at it on both sides. Log of 5 to the x equals log of 18. Now, once you take the log of both sides, what happens to the exponent? It goes in front. So you'll have x times log of 5 equals log of 18. Then you divide by log of 5. Now we want to round, it says here, to the nearest thousandth, which is 3 decimal places. So make sure you close your parentheses. 1.795. What is it? I can't hear when you're asking questions over them. 1 second, let's get the answer and then I'll answer your question. Say it again, I'm sorry. 1.7. Okay. Thank you. I didn't hear the 1 part. Because Zach was talking. Now it's your question, Zach.
Wait, so how do you put in the base number?
You don't, because you're taking the common log. Why do you not? I don't know. I don't understand what you're asking. You don't type it all. When we do these, it'll always be common log. You're never going to take like log base 3 of something. Like to solve these, Zach, you need the common log. So just the regular old log base 10. That's just how it works. Now, in B, Zach, just do a couple more here, and I think it'll make more sense to you once we get past like the first one. Now, here, I want to take the log of both sides again, right? I want to get x out of the exponent. I'm going to show you here where it's okay to me if you skip some steps, because if we take the log of both sides, what's always going to happen to this exponent? It's always going to go to the front. So if you would like to just take the log of both sides, if I take the log on the right-hand side, what's going to happen? It's going to be x times log of 4. So if you want to skip to that step, I'm okay with that. Right? Does that make sense to everybody?
Yes.
Making sure. Okay. So if I do that, that won't freak anyone out. All right. X times times log of 4. What do I have to do to get x by itself? Divide by log of 4. Now, before we move on, let's just see if we can simplify any of this. Log of 100. Let's think. Now, you can use your calculator. I'm not saying you can't type log of 100 divided by log of 4, but let's see if you can think of something. Do we know what log of 100 is? It's not 10. Think about this. What's the base here? 10. It would be 2 because 10 to the second power equals 100. So if you wanted, you don't have to, but if you wanted to, you could rewrite this as 2 over log of 4. Those are the same thing. You don't have to do that. I was just trying to remind you that you can find log. No, but you should know like log of 10 is 1 and natural log of e is 1. Those two you should know. Right? So what is log of 100 divided by log of 4? 3.32. You guys agree? All right. Now, what is the point? 3.22? Okay. Thank you. Now, what does it mean to show your work? Well, what this is just reminding you is that you found the value of x. You found this exponent here. So take your calculator for me, humor me for a second, and let's figure out, is 4 to the 3.322 power, is that close to 100? So type that in, 4 to the 3.322. Yeah, just about 100, right? Because we rounded up, so we're a little bit over. But that's what we're finding. When we take the logarithm, we are finding the value of the x. Okay? All right, so let's try a couple that are a little bit more challenging. So now we have 1.03 to the 2x power equals 2. Okay? Our logarithm law is going to work the same way. I have 2x in the exponent, but it's still an exponent that I need to move. So I'm going to throw a log at both sides of that equation. Now, if I throw a log at the left-hand side, what step can I skip to? I'm going to throw a log at it. Where's the exponent going to go? In front. So I'm going to write this as 2x times log of 1.03 equals log of 2. All right, so I'm just skipping that first step, but if that is bothering anyone, let me know and I can write it in. Now, if I need to divide here, now this is where I want you to pay attention and be careful, because there's really 2 ways that will get you the right answer. What should we do next, do you think? Divide by 2. Now, here's the thing I want to bring up. The 2, the x, and the log, they're all multiplied together, right? So, can I divide at the same time by 2 log of 1.03? Can I do that? Because that'll cross off. Okay, let's go back. 2x, that's being multiplied, right? Times log of 1.03. It's all being multiplied. So, just like if you had like 2xy equals 4 and you wanted to get x by itself, you know how you could divide by 2y on both sides here? Can you divide by 2 log? Yes, you can. Now here, you're going to have to be careful though, because this will cross off the 2. It'll make the log go away. I have to divide over here. I'll get x equals. Now, oh, I forgot the 2. When you type this into your calculator is very finicky about these things. Your calculator follows the order of operations. So if you decide to do this way, where you divide by the 2 and the log at the same time, when you type this in, you'll type in log of 2. Close your parentheses. Now when you hit divide, before you type the 2, you need to put another parenthesis. You have to say divided by the whole quantity 2 log of 1.03. Now how many parentheses will you have to put at the end? 2 of them. Put 2 parentheses at the end. And you'll end up with 11.725. Now if that seems like a whole lot of work and you're kind of like, okay, I'm not really sure why she did that. just watch for a minute here. I'm giving you an alternative that gives you the same answer. All right, this is the alternative I always use with my regular Algebra 2 classes because we don't always handle parentheses well. So just watch. I want you to watch and then decide what's going to work for you because I do not care. Let me start back from the beginning. If I have 2x times log of 1.03 equals log of 2. Here's the other strategy. My other strategy is you need to divide, right? Always divide by the log first. So you would leave the 2x alone, and divide by log of 1.03. Okay? That'll make the logs go away. And then what you'll have is 2x equals log of 2 over log of 1.03. You agree with me so far? Then how would you get x by itself? Divide by 2. So what you would do in your calculator is you have to divide this whole fraction. You haven't used your calculator yet. So if you did this in your calculator this way, I would take log of 2 divided by log of 1.03. Then hit enter. And then divide by 2. Do you get the same answer we just had? Yes. I don't care which way you like to do it. But if you do the first way, you have to put parentheses before the denominator. Okay? Either one is fine. Got it? All right, I wanted to show you both. Let's do the next one here. Go back up. All right, now I have 9 to the x over 3 power equals 13. How do I get the x out of the exponent? Take a log. So when I take the log on the left-hand side, what will I write in front of log of 9? X over 3. So I have x over 3 times log of 9 equals log of 13. Now this one I would do in 2 steps because we can't like divide by 3, we're going to have to multiply. So I would divide by log of 9 first this time. Cross those off. You'll get x over 3 equals log of 13 over log of 9, and we're not using our calculator yet because we need an exact answer. And then I would multiply both sides by 3. So when you take your calculator, I would do what we just did. Log of 13 divided by log of 9, hit enter, times 3. And tell me what you get. 3.5 what? 02? Alright, so, does that make sense so far? Yes? No? Maybe? Kind of? Yes, Rachel. What do you mean? Well, like if you put this in my calculator, I would do this and hit enter and then times by 3. So you wouldn't have to put extra parentheses. The only reason you did over here when you divided is so that your calculator knew the 2 stayed with the logarithm. But if you're worried about the parentheses, just do what I did on the bottom. Do the division, hit enter, and then divide again. Okay? All right, that's where we're going to stop today because we're running out of time today. We will pick